All right, this video is about triangles, and it's the triangle number 1 practice. So this kind of incorporates all of that information we learned about triangles, as well as a little bit of trick. So in the figure, what is the value of x? So in this problem, you actually have to recognize some angle properties, angle pairs. This angle here is 60. This angle is also 60 because those angles are what's called vertical angles. And vertical angles are always congruent. So this angle is also 60. Now in our picture, we should clearly be able to see this triangle. Triangles always add up to 180. So what you're going to do is add 60 and 40 together. So 60 plus 40 is 100. And you're going to do 180 minus 100, which is 80. And that's the measure of x for J. All triangles, no matter how big or small, will always add up to equal 180 degrees. Number 2, if cosecant is 4 over 3, what is the value of sine? So cosecant of theta, it's the opposite of sine. So instead of it being O over H, it's H over O. Sine's fraction is O over H, which means if my cosecant fraction is 4/3, then my sine fraction just flips it to 3 over 4. So sine of theta is 3 over 4. Now don't actually have to solve for theta because it wants to know what sine of theta equals. Sine of theta will always equal a fraction. So it's 3 over 4. Which of the following triples cannot be the lengths of a triangle? So this is using the triangle inequality theorem. So the triangle inequality theorem states that the sum of the two sides of the shortest sides of a triangle have to be greater than the longest. So all I'm going to do is look for the two smallest numbers, so 1 plus 2. 1 plus 2 must be greater than 3, which is the longest. Well, 3 being greater than 3 is not true. So A is my answer because I'm looking for which ones don't work. So if we were to test, like let's say D, we would add 10 plus 11, and it has to be greater than 12. Well, 10 plus 11 is 21, and 21 is greater than 12, so it will make a triangle. So if you're determining the lengths, you add the two shortest sides, and it must be greater than the longest. Okay? Option A doesn't work because they're equal. Number 4, what is the value of cosine of B? The B value, that is where theta goes because it's cosine of B. So when you're labeling your triangle with opposite and adjacent, you're going to use angle B. So across the 90 is H, across theta or B is O, and by default this is A. Remember that cosine's fraction is A over H, so I get 9 over 15. However, that's not an answer, but I can pull a GCF of 3 out of this. So 9 divided by 3 is 3, 15 divided by 3 is 5 for 3/5, which is option G. So always make sure that you're reducing your fraction. Also, you don't actually solve for B because in this problem, it just wants to know what the fraction ratio is. All right, number 5, tangent of x is 3 over 4. What is sine of x plus cosine of x plus sine of x? I would start by drawing a triangle, right triangle. X is your theta value, so I'm just going to put x over here. It doesn't matter. You have freedom to label x where you want, but it is an angle, so you can either put it here or down here. Then I'm going to label. Tangent is O over A. So to label my triangle, I have H, O, and A. Since tangent is O over A, I know that 3 goes with O, 4 goes with A. Now this triangle we should recognize as a 3, 4, 5. Now it wants to know what cosine of x plus sine of x equals. Well, cosine of x is A over H, so 4 over 5. Sine is O over H, 3 over 5. 4 plus 3 is 7. When we're adding fractions, the denominators don't change. So our answer is H. Again, we're not actually solving, we're just setting it up and we're adding the ratios, not actually finding the measures of the angles. Number 6, we are looking for which of the diagram statements is true. So I'm going to label, I'm looking for the true one. Across 90 is H, across X is O, and this is A. Sine of X is 5 over 3. Well, 5 over 3 is H over O. Sine is O over H, so F is out. Cosine is 3 over 5. Well, 3 is O, 5 is H. That's actually a sine fraction, so that one's out. Tangent equals 5 over 4. Well, 5 is H over A, and tangent is O over A, so H is out. Number 6, cosine is 4 over 5. 4 is A, 5 is H, and cosine is, in fact, A over H. So our answer is J. Just for, consistency, number 5, or option K, 4 over 5, that's A over H, which is cosine. So K is definitely not true. So again, all you're doing here is just looking at the fractions and seeing which one is actually set up correctly. So as far as the trig is concerned on the ACT, it's really not that bad. It's just a lot of remembering the equations for trig and SOHCAHTOA. All right, this next one wants to know the value of AC. So that's the length, that side measurement. It tells you AB is 4 and ACD is 135. I would look to see that this is a linear pair, which means that it adds up to 180. So 180 minus 135 is 45. These triangles must add up to equal 180, so 90 plus 45 is 135. Subtracting, I get 45. Now, I have two congruent sides, which means that these two legs are equal. This is isosceles. Now, you could definitely do trig if you wanted to. So if you found out this to be 45, you could always do the sine of 45 equals opposite 4 over hypotenuse x, and then just change your answers to decimal. Or you can use Pythagorean theorem. So 4 squared plus 4 squared equals x squared. 16 plus 16, I end up with the square root of 32. 32 can be broken down into 16 times 2. Square root of 16 is 4, square roots of 2. When we learn about special right triangles, this is actually a special right triangle called a 45-45-90. We will learn about that after we learn law of sines and cosines. So for right now, these are the two potential ways that you could solve them. So if you did it by using trig, you would just change your answers to decimals. And then if you used it with Pythagorean theorem, you would just simplify your radical. All right, let's try number 8. A polygon is not a triangle if it has exactly 3 sides. Well, if it has exactly 3 sides, it definitely is a triangle. Like if I'm drawing a triangle, it has to have 3 sides. So A is out. I'm looking for the one that won't be a triangle. B, it has exactly 3 angles. Well, if it has 3 sides, it's got to have 3 angles. C, it's not a triangle if it has exactly one of its angles measuring 135. Well, we could definitely have an angle being 135. This would just be an obtuse triangle. So it can be a triangle. It has 2 perpendicular sides. If it's got perpendicular sides, that means that it has a 90 degree, which would make it a triangle. The correct answer here is E. If I were to draw parallel sides, there is no way I could ever draw just one more segment and make a triangle. So I can't have parallel sides in a triangle. I can only have parallel sides starting in 4-sided figures such as squares or rectangles or parallelograms. All right, number 9, in the figure, AC equals CD. So AC, CD. Find the number of degrees for ADE, which is out here. This problem is not as hard as it looks. It's linear pairs and isosceles triangles. So it gives you 30. This right here is a linear pair. So 180 minus 30 is 150, making this side 150. Now, if I'm focusing on this triangle over here, because my goal is eventually to get to X, if I'm focusing on this triangle right here, okay, that triangle has to add up to 180 degrees. It is also isosceles because it has 2 congruent sides, which means it also has 2 congruent base angles. So what I'm going to do is 180 minus 150 is 30, but then I have to divide that 30 in half, which is 15. Remember, this triangle, regardless of how I draw it, it has to add up to 180. So now that I know that that angle is 15, I can now use another linear pair and do 180 minus 15 to get an answer of 165. So 9 is hard, especially if you don't notice that it's an isosceles triangle. It kind of pieces apart 3 different ideas. You have to know linear pairs, you have to understand isosceles triangles, and you have to know that triangles add up to 180. All right, number 10. In the figure, it's a right triangle. So obviously the 90 is here. It gives you the units. It wants to know AC. I would not use trig here. I would just do Pythagorean theorem. So 4 squared plus 6 squared equals x squared. 4 squared plus 6 squared is going to give me 36. Just kidding. It's going to give me 52. 4 squared plus 6 squared is 52. Then on I square root, I get the square root of 52. Multiplying here, I would get 4 times 13. Well, the square root of 4 is 2, and the square root of 13 cannot be simplified. So it's D. I would just recommend Pythagorean theorem on number 10. Number 11, it tells you C is 90 and that these are straight lines, which lets you know right here that you have vertical angles. So that's kind of the clue. They've got to be opposite rays. They have to form lines. It says BED is 50. What is A? So again, we're using some vertical angles. So if this is 50, so is this one. Now you should see a triangle. That said triangle should add to equal 180 degrees. So 90 plus 50 is 140. So 180 minus 140 is 40. So A is 40. Any triangle, regardless of size, will always add up to 180. All right, next one. Couple ways to do these. If you have memorized these special trig ratios, then awesome, use them. If you don't, I would recommend putting the numerator in parentheses and the denominator and just doing it in your calculator. So to do it in your calculator, it's got to be in degree mode. I press mode, go down, degree is highlighted, so I can quit out. Also, if you have a newer calculator, it should tell you right here. So on the top, I'm going to have the sine of 30, or excuse me, the sine of 60, close parentheses, times the cosine of 30, close parentheses for the trig function, close parentheses for the numerator. So right here, it's going to open parentheses. So this is what it's going to look like in your calculator. I'm going to divide said answer by tangent of 45. Enter. 0.75, math, enter, 3/4, which is option C. So just do it in your calculator, but pay attention to the parentheses. Now, if the parentheses freak you out, you can also do it this way. Sine of 60, close parentheses, times cosine of 30. Oops, I opened cosine twice. There you go. Enter, divided by tangent of 45. Okay, so you can do it in pieces if you want to, totally fine. All right, number 13, in the triangle below, what is the value of x? So I have hypotenuse, opposite, adjacent. This is cosine. So cosine of 60 equals x over 6. Clear the fraction by multiplying by the denominator. So I get 6 times cosine of 60. 6 times cosine of 60, I'm going to put in my calculator. So 6 cosine of 60 is 3. This is also a special right triangle. This is referred to as a 30, 60, 90. We will get to those after we learn the law of sines and law of cosines. And the last one on this worksheet, we want to find the value of x minus b. So to start, I have to look at my picture. I have to use this b value. Well, if this is b because they're vertical. Also, we learned about what's called the remote interior angle theorem or the triangular exterior angle theorem. So 1 and 2, these two angles that are remote interiors, they're going to add to equal whatever is on the outside. Same thing here. 60 plus b has to add to equal what's on the outside, which is x. If I want x minus b, that means I have to subtract b. So 60 equals x minus b. So the answer is A.